You were told gravity is a force, a giant invisible hand pulling you toward the Earth. You learned it in school. Newton described it with equations, and for 300 years, everyone believed it. But Einstein realized that it's actually a lie. Gravity isn't a force at all. It's the shape of your reality. Space itself is not flat. It bends, it curves, it warps, and everything you call gravity is just objects following the natural contours of a curved universe. Today, we're going to visualize the invisible fabric of spacetime, walk through Einstein's field equations step by step, and reveal why you aren't actually falling right now. You are being pushed upward by the ground beneath you. In physics, objects want to move in straight lines. No force means no curve. This is Newton's first law. An object in motion stays in motion unless acted upon. But when mass enters the room, it bends the grid. Watch this. Imagine two people walking perfectly straight toward the North Pole. They start out parallel to each other. No force pushes them, they are just going straight. But they end up colliding at the pole. No force pulled them together. The geometry of the Earth did. That is exactly how gravity works. There is no hand pushing the planets. The curvature of spacetime does it all. Watch this grid bend as a massive object appears. This is spacetime itself being sculpted. Every single kilogram of matter does this. Your body bends spacetime right now, just barely. A planet doesn't get pulled into orbit. It follows the straightest possible path through curved space. We call these paths geodesics. A geodesic is the GR equivalent of a straight line. The planet isn't turning, space is turning around it. Einstein encoded all of this into a single equation. It looks terrifying at first glance. 10 coupled, nonlinear partial differential equations packed into tensor notation. But once you see what each part means, it becomes almost poetic. At its core, the Einstein tensor G equals the stress-energy tensor T geometry equals matter. That is literally it. The shape of space equals the stuff inside it. The full equation adds lambda, the cosmological constant, which describes dark energy pushing the universe apart, and kappa, the coupling constant that sets the absolute strength of gravity. Change kappa and you change how strongly matter bends space. The left side describes the geometry of spacetime. How curved is space right here, right now? The right side describes all the matter and energy present. How much stuff is here? It's momentum, pressure, energy density, all packed into one tensor. This equation is a two-way conversation. Matter tells space how to curve, and curved space tells matter how to move. Spacetime and matter are in a continuous dialogue, every moment, everywhere in the universe. Let's see what that conversation looks like. As a massive star appears, flat spacetime bends into a deep gravitational well. In the next section, we will view this in full 3 dimensions. And a planet simply follows the curvature. What we perceive as gravitational attraction is just freefall along a curved surface. Now let's go into 3 dimensions. This is the spacetime well, the actual shape of space around a massive object. Every bit of mass creates exactly this kind of depression in the fabric of reality. This marble isn't being pulled by anything. It simply rolls along the curved surface, following a geodesic, the straightest possible path through warped geometry. That is every orbit, every moon, every planet. Now watch what happens when we increase the mass dramatically. The well deepens. At extreme densities, like a neutron star, the well becomes so steep that escape velocity approaches the speed of light. Keep adding mass, and you get a black hole. Here is the smoking gun that proved Einstein right. If gravity were just a force acting on mass, then light, which has no mass, should travel in a perfectly straight line, completely unaffected by any nearby star. On the left, flat space, no mass nearby, a photon sails straight through without deflection. On the right, a massive star warps the grid. Watch what occurs when we place that star in the path of light. Light bends, not because a force grabbed it, but because the space it travels through is curved. The photon is still going in a straight line, It's just that straight lines themselves are curved in a curved spacetime. We observed this during a solar eclipse in 1919. Astronomers measured starlight bending around our own sun. Einstein's prediction was exact, within the margin of experimental error. This single observation ended Newton's 300-year reign and ushered in the era of modern physics. Spacetime isn't just a concept, it's a physical fabric. And if spacetime can curve, it can curve infinitely. A black hole is a region where spacetime has curved so much that not even light can find its way back out. The gravitational well has become infinitely deep. The boundary of no return is called the event horizon. Cross it, and the laws of physics as we know them break down completely. Time itself slows to a stop for a distant observer. Gravity isn't a pull. It's a push from the very fabric of existence. You aren't falling toward Earth right now. You're following the straightest path through a universe that is constantly being shaped by everything in it. The chair beneath you, the floor, the Earth's entire mass, they are curving spacetime just enough to accelerate you upward at 9.8 meters per second squared. If this visualization helped you see the math, drop a like and hit subscribe. Tell me in the comments what concept I should animate next. And share this with someone who still thinks gravity is just a force, because now you know better.